Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 9 in the XXE injection module, titled Exploiting XXE to Retrieve Data by Repurposing a Local DTD. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on XXE injection vulnerabilities, and then go down to lab number 9 titled Exploiting XXE to Retrieve Data by Repurposing a Local DTD. Alright, let's get started. This lab has a check stock feature that parses XML input but does not display the result. To solve the lab, trigger an error message containing the contents of the XXE passwd file. You'll need to reference an existing DTD file on the server and redefine an entity from it. Alright, so the target goal over here is to exploit an XXE injection to trigger an error message that contains the content of the XXE passwd file. We also get a hint over here saying systems using the genome desktop environment often have a DTD at this path over here containing an entity called ISO-AMSO. So this is the entity that they would like us to redefine. Now what we're going to do is we're going to assume we didn't get this hint and try to identify this DTD by ourselves and then identify this entity that we need to redefine. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version of Burp just because I will be using some of the features that are only available in the professional version. However, you don't need those features to complete the lab, so if you have the community edition, you could just complete the lab with the community edition. Alright, the first thing we're going to do is find a parameter in the application that accepts XML input. So let's click on View Details, go down, select Check Stock, and then send this request to repeater. In repeater over here, we see that it's a post request to the /product/stock endpoint. And if we go down, you could see it takes in XML as input. So whenever you see XML in the application or an indication that the application is using XML, that means you definitely need to test for XXE injection. And that's exactly what we're going to do. So let's put this over here. And then start off with testing for the irregular entity. So what we're going to do is define a DTD, so doc type, and name it test. And then we're going to use an external entity to try to output the content of the passwd file. So we're going to say entity. We'll name it XXE. We'll use system because it's an external entity. And what we're trying to access is the passwd file. Okay, let's copy that. Now in the request over here, when we hit send, you could see it displays the items that are left in stock for this product ID and this store ID. So what we're going to do over here is add our DTD right before the root element, and then we're going to hit send to see if the application accepts it. So far so good, so the application didn't error out. Now we need to reference our external entity, so we'll say and XXE, hit send. And it says invalid product ID. Alright, so when we didn't reference the external entity, we didn't get an error. However, when we did reference it, we did get an error. We don't have any luck with this one. Next, we'll try with a blind regular entity. So this is really similar to the regular entity over here. except what we're going to do is try to ping our attacker-controlled server. Because if the application has some kind of defense in the backend that only outputs integers, then regardless of what entity or what file we try to output over here, we'll never see the output in the application. So we're going to see if we're able to ping our attacker-controlled server. To do that, we remove this whole thing over here and then say HTTP, and then we need the link to our attacker-controlled server. So we go on burp collaborator client, and then copy to clipboard and put it in here. So burp collaborator is only available in the professional version, and so you won't be able to use it if you're on the community edition. So let's copy this, put burp collaborator right over here and make it a little bit smaller and put it in here. Hit send. We still get invalid product ID. Let's click on poll now to see if we get a ping back, and we don't. All right, so this didn't work. My guess is the application does not allow me to reference external entities. And so what we're gonna try is something called a parameter entity. So this lab is pretty much a summary of all the previous labs because we already learned each and every type of these entities in the previous labs. All right, so a parameter entity is really similar to a regular entity with two exceptions. So when you reference the entity, you have to use the %, and the entity is only referenced from within the DTD and not outside of the DTD. So we're gonna put 1 over here, hit send. We shouldn't get an error. So over here, we get the number of items that are left in stock. And then what we're gonna do over here is reference it within the DTD. So %XXE and then semicolon. Let's copy this and put it in here. Hit send. And this is interesting. So instead of getting the custom error that we've got an invalid product ID, right now we get an error from the XML parser. Good news is that since the application outputs the error of the parser, we might be able to use that to our advantage to output the content of the passwd file. So there's one more thing that we could try, and it's called repurposing a local DTD. Now, to use a local DTD, we need to see if the error allows us to identify if the DTD exists on the system or not. So what we're going to do is call a non-existent DTD and see if the error tells us if it exists. So let's copy this over here. A blind entity might have not worked because they might have had egress filtering, and so the server can't ping to an external domain, and so this is a dead end for us. So what we're going to do is we're going to try again with the file keyword and try to access a DTD that does not exist. So let's say XXE does not exist, so we know for sure that this file doesn't exist on the system. Let's copy it, put it in here. Hit send, and the error changes. So you could see over here it says XML parser exited with error, and it says XXE / does not exist. This is a really good sign because right now it's telling me that the application, first of all, is processing my XML input, and second of all, if I get the application to somehow trigger an error message containing the contents of the XXE passwd file, then I can essentially read arbitrary files on the system. So let's try that. The first thing that we need to do is find a DTD that already exists on the server. Now, if you Google this, you'll see that there are common DTDs. In the exercise over here, they already gave us the URL for the DTD, but we're going to assume that we didn't get this hint because we want to pretend that this is a real life engagement. And what we're going to do is we're going to Google, go secure, and then let's say DTD XXE, hit send, click on the first link, And this looks like it's taking a really long time. I'm not sure why. So let's just go to the XXE payloads.md file and maybe go to it directly. Maybe the browser is not working properly. Here we go. So just this tab over here. All right, so the idea over here is if you go to DTD Finder, you could see that it's a tool that GoSecure has built to identify DTDs on the file system. Now, we're not going to use the tool. What we're going to do is we're just going to take the list of most common DTDs and then fuzz our application using our XXE injection to identify which one is valid and which one is not valid. So to do that, let's click on List, select DTD files, and then click on Raw, and just copy this entire thing over here. And then we're going to go back to burp. Let's see if this request didn't time out. It didn't. Let's send this to intruder. In intruder, let's clear everything. And the request that we want to fuzz is this one right over here. So click on add. And then in payloads over here, click on paste to paste the list. So essentially what we're doing over here is we're going to fuzz this parameter over here, or this portion of the parameter over here. And if we get a 200 OK message, that means that the DTD exists on the system. If we get a 400 message, so if we go back to repeater, so a 400 bad request, that means the DTD does not exist on the system. Now, there is something that you need to be careful of. The XML won't work if you allow URL encoding. And so you need to check this off, saying that you should not URL encode the characters. Let's hit Unstart Attack. And again, this is heavily throttled in the Community Edition, and so you do need the professional version to complete this. All right, let's sort on status. Now you could see over here, there's a bunch of 200 OK, so these DTDs all exist on the system. And then there's a bunch of 400s, which means that these DTDs that we tried don't exist. So you could see in the response over here, it says no such file, whereas if you click on one of the 200 OKs, you get the response of the request, meaning that it does exist. Now, if we go back to the exercise over here, in the hint, they gave us a DTD at the path user, share, Yelp, DTD, and then docbook x.dtd. And you could see over here, it's one of the DTDs that we were able to enumerate. So you could either use the hint or you could try to enumerate it yourself if you have the professional version of burp. All right, so we've identified that this DTD exists. Let's send this request to repeater and then work from there. So if we hit send, you can see over here we no longer get the error. Let's close this off and discard. And let's also close our collaborator instance. All right, so now we've identified the DTD that does exist on the server. Now the next step is to overwrite an entity in this DTD and get the entity to error out and output the content of the etc passwd file. Now, we're not going to try to do that our own selves. What we're going to do is we're just going to copy this path over here and then go again to Google. And in there, we're going to put the path and then add the keyword XXE injection, hit send, and see if there's any entries where someone already tried to perform an XXE injection using this DTD. So it's on the same page, GoSecure, hit send, click on it, and let's go down and see if it has the payload. Now over here, the DTD is font config. That's not what I'm looking for. I'm looking for doc book x.dtd. And it looks like it didn't give me an entry for how to overwrite an entity in there. So let's go down again. Let's select this and see if we could find it here. So find doc. And here we go. So under payload all the things, you could see that it's using the docbook x.dtd. And in there, it's overwriting the ISO AMSA entity in order to overwrite whatever file path that you put in here. Now, if we go back to the exercise hint over here, it gave us a hint that the entity that we need to overwrite is the ISO AMSO entity. So we're on the right track. Let's copy this entire thing over here. Let's put it in here. And then over here, the file that we're going to try to read is the etc passwd file. Let's copy all of this, put it in burp, paste it, hit send, and here we go. So we get the content of the passwd file, and if we go back to the application, we should see the congratulations, you solved the lab exercise. All right, so just a quick explanation of what we just did. Essentially, we went online and we Googled for this specific DTD, is there an entity that I can overwrite to generate an error that will output the content of the file that I want? And we found that someone has already done the research on this entity over here, and these entities are usually open source, so you could go in and try to identify which entity on your own. However, someone has already done it before, and so we just copied the exploit and we performed it in our request. This is really similar to server-side template injection, where we identify which templating engine the application is using, and then we don't need to identify on our own how to exploit the templating engine, because it's very likely that someone has already identified how to exploit an SSTI vulnerability in that template injection, and so we just need to review the previous research that other people have done. But essentially, at a high-level overview, what's happening over here is we're defining an XML parameter entity called local DTD. It contains the contents of the external DTD file that exists on the server. So this one right over here, which we identified is a valid one by performing this test over here. And then in this step over here, what we're doing is we're essentially redefining the XML parameter entity called ISO AMSA, and we're redefining it to contain the error-based XXE exploit that we learned about in a previous lab. So when it does error out, it'll say the content of the file, let's say abcxyz / the path of the etc passwd file does not exist. And so it'll output the content of the passwd file over here. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. First thing we're going to do is import all the libraries that we want. So the request library, the sys library, the URL lib3 library, and then we're going to disable insecure request warnings. So URL lib3.disable warnings, URL lib3.exceptions.insecure request warning. And then we're going to set our proxy settings. So proxies is equal to send all HTTP traffic to where burp is running, which is on HTTP 127.0.0.1, port 8080. Same goes for all HTTPS traffic that should be sent to where burp is running, which is on HTTP 127.0.0.1, port 8080. The next thing we want to do is call and define our main method. So if name is equal to main, then call the main method, and we'll define it right over here. So if the length of the command line arguments, so sys.argv, is not equal to 2, then print the usage and the example instructions. So if you don't put in 2 command line arguments, then you don't know how to run the program. And so what we're going to do is we're going to print the usage instructions first, which is usage, name of the program, and then URL, and the name of the program we take from the command line argument. And then we'll also print the example instructions just so that it's absolutely clear how to run the program. So example, www.example.com, and the name of the program from the command line argument. All right, and then I'll exit the program because the user ran it incorrectly. Now let's assume the user did run it correctly. The first thing we're going to do is initiate our sessions object. So requests.session. And then we're going to create a variable called URL and take that from the command line argument. So sys.argv1. And then we're going to call a function called exploit XXE that takes in the session object and the URL. Now this is a custom function that we'll define right over here. So def exploit XXE, which takes in the session object and the URL. This function will be responsible for performing this request right over here and outputting the content of the passwd file. So we'll first print exploiting XXE injection. And then we'll create a new variable called stock URL. That's the URL to the vulnerable function. So the URL of the main application plus this path right over here. Let's copy that. And then we need the content of the post request. So we'll name that data stock. And that would be our entire XML document over here. So let's copy this. Now this has single quotes and double quotes. So to add it all as a string, I'm going to use triple quotes. And of course, we need to remove all new lines. All right, this looks good. Let's click on View and Word Wrap. Hopefully there's no errors, although this is highlighted, but I don't think that should be an issue. Next, we're going to say R is equal to s.post, so we're performing a post request. It takes in the stock URL. Data is equal to data stock, which we just defined. Verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want our request to be sent to burp. And then we're going to print the following is the content of the etc passwd file. And to get that content, we just need to print the response of the request, which is r.text. So it'll print this entire thing over here, including the content of the passwd file. Okay, this looks good. Let's save it. Go to terminal, new terminal. And the application might have timed out. Hit send. And it did, so we need to generate a new instance of the lab. Let's close everything. Access the lab. And over here, we'll say Python 3, XXE injection lab09.py, and the URL of the application. Let's copy that, paste it in here, and remove the trailing slash and hit enter. So far, so good. And here we go. So you could see it outputted the content of the passwd file, and you get the message, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python.